The center of a circle lies on the line x plus 2y minus 6 equals 0. The x-axis and the y-axis are tangents to the circle. There are two circles that satisfy these conditions. Find their equations. Now, without doing any calculations, I drew the line x plus 2y minus 6 equals 0 by just picking 2 points on it. So I let y equals 0 and I got x equals 6. So I went out 6 units here. By letting x equals 0, I got y equals 3. Went up 3 units here. I drew the line. And then just by experimenting, I found two circles whose centers are on this line. This is the center of the larger circle, and as you can see, it touches both axes. And the second circle is center here. Its coordinates, as you can see, are actually 2, 2, and it touches both axes. For this part of the line, we cannot draw a circle centered on the line that will touch both axes. So you can actually read off the centers and get the radii of both of these circles. Let's see how to do it by calculation. HK stands for the center of any circle. We know that it's on this line here. So if it's on the line, it must satisfy the equation of the line. So we just plug H in for X and K in for Y. So now we have one equation with two unknowns. Notice that the distance of this center to both axes is the same. The distance is r. So what does that tell us about these coordinates? It's the same here actually. Well, it tells us that either h is equal to k, which is the situation for this circle, the x and y value of the center of this circle are the same, or we have a situation where h is minus k, which is what we have here actually. The center of this circle is actually meant to be at minus 6, 6. I haven't drawn it that accurately. I should have put the center here. So you can see h is negative here because the point is in this quadrant. K, however, is positive. But h and k are related by this relation. H is actually minus 6 for this circle. K is actually plus 6. So minus 6 equals minus 6. Anyway, so this is the situation for circles touching both axes. Either the x and y values are the same, or they have opposite sign, but are the same in magnitude. So in general, we could say that the magnitude of h equals the magnitude of k for circles that touch both axes. And from this relation, this magnitude relation, we get these two equations. And these are the two equations that we work with. We can't really work with this. I think that this fact is so important I've decided to highlight it, and it's an easy way to actually answer this question. So let's first consider the situation where h is equal to k. We just go to the equation of the line and set h equal to k. So we'll get k plus 2k minus 6 equals 0. So we can solve this for k. We get 3k minus 6 equals 0, or k equals 6 divided by 3, which is 2. And you can see straight away that this circle is drawn accurately. The y value of the center is 2. Well, we said h is equal to k, so if k is 2, that means that h must be 2. So now we have the center of one of the circles. Its center is 2, 2. And it's very easy to get the radius, because the radius is just the magnitude of either h or k. Well, the magnitude of 2 is 2. So now we can easily get the equation of this circle. We have our equation of a circle formula, so we just plug in for h, k, and r. And here's the equation. Now let's look at the other situation, the situation where h is equal to minus k. That'll give us this circle over here. So we just plug minus k in for h in here. So we're going to get minus k plus 2k minus 6 equals 0. Solving this, we get k minus 6 equals 0, or k equals 6. If h equals minus k, it means that h equals minus 6. So the center of this other circle is hk, which is minus 6, 6. And the radius is just the magnitude of h, well, the magnitude of minus 6. Or if you like, the magnitude of k. Doesn't matter, we can get the magnitude of h or the magnitude of k. We get 6. So here is the equation of the second circle. We just plugged minus 6 in for h and plus 6 in for k. Also 6 in for r in the equation of a circle formula. And this is what we get. So as I said earlier, when I was drawing this circle, I should have put the center here at minus 6, 6. But anyway, you know, you have to know how to calculate it. So I would recommend keeping this result in mind anytime you're dealing with a question involving circles touching both axes. And it doesn't matter where the circle is centered. It could be centered in this quadrant here. Then either h is equal to k, or h is equal to minus k, and the radius is just the magnitude of either h or k. Similarly for any circle centered in this quadrant. So it works anywhere.